Alright, so we've used a couple of different units in our examples of measurement and significant figures, but let's just take a little bit of time to talk about them in more detail. In chemistry and most of the sciences, we use the metric system of units. And so if we're talking about volume, the base unit is the liter, has abbreviation of L. If we're talking about units of distance, the base unit is the meter. It's abbreviated lowercase m. For mass, the base unit is the gram, which has the abbreviation of lowercase g. Time is fairly constant throughout the different systems, and that of course is the second, abbreviated S. Okay. We'll talk about temperature in a future discussion, but another type of unit or measurement that we want to talk about now would be energy. Because as we are going to see, anytime there's a change, whether it be a physical or chemical or nuclear, energy is being transferred. And so there are actually two types of units that we use for energy. The first one is a little bit older, and that's the calorie. That's abbreviated CAL. And more recently, most chemists take on the units of joule for energy, and that's abbreviated capital J. Now the calorie, lowercase c, sounds very familiar, as in case for nutrition or health purposes, but that is actually for nutrition or health. They use capital C, calorie, which, as we talk about in chemistry, equals 1,000 of the lowercase calories. If you see a calorie on a label for any food, even if it isn't capitalized, that's what they're talking about. They're talking about 1,000 of the calories that we'll talk about in this course. In chemistry, when we talk about measurements, we have to talk about really big numbers and really small numbers almost interchangeably or in the same sentence. And so it would be convenient to come up with a system for talking about large numbers or small numbers. One way to do so we've already discussed, and that is scientific notation. And the second way is to use prefix multipliers. And those are prefixes to give you information about whether or not you are larger or smaller than your base unit. Okay, so you can use any base unit for this for prefix multipliers. Let's say we use the meter. Okay, you're going to have values that are larger than your base unit, and you're going to have values that are smaller than your base unit. We're going to have a prefix to describe values in both scenarios. All right. So if you have 1,000 meters, or another way to say that is to put it in scientific notation, is 10 to the third meters. That is also equal to 1 kilometer, km. If you have a million, 10 to the sixth meters, that is 1 mega, uppercase capital M, 1 megameter. If you have a billion, or 10 to the ninth meters, that is also equal to 1 gigameter. And then one more common unit above that is 10 to the 12th, or a trillion meters. It is also equal to 1 terameter. Now those prefix multipliers should sound a little bit familiar, as these are the common prefix multipliers used in computer technology. Small files might be a couple hundred to 1,000 kilobytes. Internet speeds are on the megabyte or millions of bytes per second. Hard drives are on the order of a couple hundred gigabytes or a couple hundred billion bytes worth of storage. And even more common, or becoming more common these days, are hard drives with terabytes or a trillion bytes worth of storage on them. If we go smaller than the base unit, we'll switch our prefix, or our scientific notation to the other side. So if you have in 1 meter, there are 100 or 10, 10, we'll start off with 10 decimeters. And this is a very common prefix multiplier for units of volumes for patients. Patients that are dehydrated often get deciliters of fluids, which is 1/10 of a liter. All right, so 1 meter equals 10 decimeters. 1 meter also equals 100 or 10 to the second centimeters. Even smaller than a centimeter is the millimeter, and there are 1,000 millimeters in 1 meter. What helps me to remember those prefix multipliers are the sort of thinking about the value with the prefix, and this is actually pretty straightforward. Decimeter, I think decade, 10 years. Centimeter, century, I think 100 years. Millimeter, milliliter, I think millennium, that's 1,000 years. So I know that there's 1,000 milliliters or 1,000 millimeters in 1 meter. Even a little bit smaller than the millimeter is the micrometer, and in 1 meter there are 10 to the 6 or a million micrometers. And that letter is the Greek letter mu, and it looks like a U with a front tail on it, and that is the micrometer. Okay, you'll notice that when I started talking about base units that were smaller, or prefix multipliers that were smaller than my base unit, my exponent came over to the side with the prefix multiplier. We can write these equalities a couple of different ways. As I said, you can use any base unit, so I can say that there's 1 liter. In 1 liter, there's 1,000 milliliters. I can say the exact same thing, but saying it in 1 milliliter, there is 1/10,000th of a liter. And if I'm using the prefix, or the exponent on the side of my base unit for prefix multipliers that are smaller, that has to be a negative value. These are saying the same thing, just in slightly different ways.